In today's class we'll be talking about solving a simultaneous equation by matrix method. So in the previous classes that you have learned about solving a simultaneous equation by using different methods. The method used to be elimination method, substitution methods, or graphical method. Today you are going to learn something new for class 10 SE students in Nepal. Today you are going to learn something new to solve a problem, to solve a simultaneous equation by using a matrix method. You also have to solve a problem by using a Cramer's rule in the same chapter. But first we are going to deal with the matrix method. So here the given equations are 3x plus 2y equals to 8 and 2x minus 2x minus y equals to 10. So now we are going to solve the given equation. Okay. First, writing in the matrix order, writing in the matrix form, matrix order, whatever you prefer, writing the matrix form. So when you write this in a matrix form, you get, see now the way to write in the matrix form. The coefficient of x here is 3, so write here 3. The coefficient of y is 2, so write here 2. Now go to the second equation. The coefficient of x here is 2, and the coefficient of y here is minus 1. Now the variables so involved here are x and y. X is in the numerator, y is in the numerator. Same thing happens in both equations. Equals to. Now the constant term after equal to is 8 and 14. We denote it a x equals to b. Therefore, when x is equals to b, then x equals to a inverse b. Now this is how we find the answer. This is capital letter X. We will find the value of this capital letter X, which is a inverse b. Now you can clearly see that you can take this as a formula as well. X equals to a inverse b. You can take this as a formula as well. Or you can understand that if ax is equal to b, then x becomes a inverse b. Now we are going to find a inverse. The way to find a inverse is exactly the same way that we did yesterday. So we have a equals to 3, 2, 2 minus 1. Now we'll find a inverse. To find a inverse, first we need determinant of a. The way to find the determinant of a is very simple. First multiply 3 and minus 1. You get here 3 into minus 1 minus. Now multiply the remaining two elements, 2 into 2. So 3 into minus 1 is minus 3, 2 into 2 is 4. So you have here minus 7. The determinant of matrix A is minus 7 here. Now we know how to find the inverse of the matrix. Now see, here we go. Then A inverse is equals to 1 by the determinant of A into adjoint of A. Now 1 by the determinant of A is minus 7, and now to find the adjoint of A, what we do is we change the place of the elements in the principal diagonal. Means here is 3 and A is minus 1. Now we change their position. Minus 1, 3. Now these 2 and 2 are remaining elements. We change the sign of the remaining elements. Minus 2, minus 2. Now we got here A inverse B. Now since we have a x equals to a inverse b, okay, here we have, since we have x equals to a inverse b, since we have x equals to a inverse b, then now we are going to put the value. What is x here? X is xy. Remember, ax equals to b. Yeah, we had written here ax equals to b previously. So a is the element here, x is the element here, b is the element here. So x equals to a inverse b, and a inverse is 1 by minus 7, minus 1, minus 2, minus 2, 3. B is the constant terms after the sign equal to. So the constant term after the sign equals to is 8 and 10. Now here we go now. Or xy equals to 1 by minus 7 similar way. Now first we multiply these two elements. Okay, way of that you know to multiply. Here minus 1 into 8 is minus 8 plus minus 2 into 10 is minus 20. Minus 2 into 8 is minus 16 plus 3 into 10 is 30. xy 1 by minus 7. Okay, minus 18 minus 20 is minus 28. Minus 16 plus 13 is 14 plus 14. Now we multiply this 1 by minus 7 into minus 28. 1 by minus 7 into minus 28 is 4. 1 by minus 7 into 14 is minus 2. So on equating, now we are equating the elements. So on equating we get that x equals to 4 and y equals to minus 2. So this is the solution for our answer. Now if you want to check whether you are correct or not, you can check the answer by putting these values here, by putting x as 4 and by putting y as minus 2, and checking whether putting x as 4 and y as minus 2 satisfies the condition to be 8 or not. Let's check it. This checking is not necessary for the perspective of examination, but still you can content yourself, means you can satisfy yourself proving that your answer is correct. So let's put as x equals to 4 and y is equals to minus 2. X equals to 4 and y equals to minus 2. Now when you solve it, we have to obtain this 8, and then only we will be sure that our answer is correct. 12 plus into minus is minus, 2 into 2 is 4, 2 by minus 4 is 8. Similarly, the same value should be satisfying this equation also. We put x as 4 and y as minus 2. 2 4s are 8, minus is plus 2, 8 plus 2 is 10. So these values satisfy both equations, so we can be sure that these values that we have obtained are correct. Okay, here we have the second question for solving a problem by the matrix method. You can see that the problems have been given in the form of fraction, but instead you don't need to worry about the way the question has been given. It is the way we solve this problem is similar to the way we solved the previous problem, but still pay attention to. Let's see how we got here. Given equations are 3 by x minus 2 by y equals to 1 by 24, and here you can see that 3 by y plus 4yx equals to 1 is given. Since we have x here at first, so let's write this x here at first. 4 by x plus 3 by y equals to 1. Please don't get confused. Here is also we are putting it in the same order. Here is x, here also we put here x, here is y, here also we put here y. So in that way we wrote it. Now writing the matrix form. So when you write in the matrix form, how we get here? Here in x you have 3. Here the coefficient of 1 by x is 3, and the coefficient of 1 by y is minus 2. Here the coefficient of 1 by x is 4, and the coefficient of 1 by y is 3. Now here you can see x in the denominator, so here you write here 1 by x. Here also the x is in the denominator. It will be given the same way. Here y also is in the denominator, so here we write here 1 by y. Here also y is in the denominator, there also we write here 1 by y. Now the constant from after equality is 1 by 24 and then 1. We call it a x equals to b. It means this is a, this is x, and this is b. Therefore, when ax is equals to b, then x will be a inverse b. Now our work is to find the inverse of a. So for a inverse, we have a as 3 minus 2 4 3. This is our a. Now we are going to find the determinant of a. To find the determinant of a, we multiply the principal diagonal. 3 into 3 gives 9, minus 4 into minus 2 gives minus 8. So 9 plus 8 equals to 17. We got as a. We got the value of here a. We got a here. Now we are going to find the inverse of A. Now to find the inverse of A, now see, then A inverse, we have the formula to find the inverse, 1 by determinant of A into adjoint of A. This is A inverse. 1 by the determinant of A is 17 here, and the adjoint of A. We have discussed earlier how to find the adjoint of A. We first change the elements in the principal diagonal. This is 3 and this is also the 3. So when we change, again we have here 3 and 3. Now we change the sign of the remaining elements. Minus 2 changes to be plus 2 and 4 changes to be minus 4. We got our A inverse. Now we have already obtained that x is equals to A inverse B. So now since we have that x equals to A inverse B, we will start with the same portion from the top. Okay. We have x equals to A inverse B, and x is 1 by x, 1 by y. Okay, so we are writing A inverse is 1 by 17. We had obtained it previously. 3, 2, 4 minus 3, and this is B is the constant term after equal to 1 by 24 and 1. Now 1 by 17 is kept as it is. Now we are multiplying these two matrices. 3 into 1 by 24 plus 2 into 1. 3 into 1 by 24 plus 2 into 1. Similarly, minus 4 into 1 by 24 plus 3 into 1. Now when we calculate it, now we are going to add it. 3 1 is 3, 3 8 is 24. Now we are going to make a calculation. Here we get is 17 by 8. If you don't know how to use this thing in a calculator, then please pay attention here. You have minus 4 into 1 by 24 plus 3 into 1. 3 into 1 is 3. You can directly write that one. This is how you have to press. You have 17 by 6 here. 17 by 6 here. Now, furthermore, now you have to multiply that 1 by with 1 by minus 70. This multiplies the term inside here. 1 by x, 1 by y. 1 by 17 to 17 by 8 gives 1 by 8. 1 by 17 to 70 by 6 gives 1 by 6. Now we equate the terms. On equating you get that 1 by x equals to 1 by 8. So x equals to 8. Similarly, you also get that 1 by y equals to 1 by 6. So y equals to 6. This is how we solve the answer. It's quite easy. Now you can put the terms in the given expression to check whether you are right or wrong. Thank you. We have here one more equation. So we are going to solve this equation by using a matrix method here. So let's see. First of all, we wrote the given equation, and we're writing the form of matrix. We're writing this in a matrix form. So when you write this in a matrix form, we get like this. The coefficient of x here is 3. The coefficient of y here is 2. Y means it is 1 by y here is 2. The coefficient of x here is 7. And the coefficient of y here is 1 by y here is minus 3. So this is matrix X. Now we wrote this in a matrix form. So now after writing this in matrix form, see the coefficient of x here is 3. The coefficient of 1 by y here is 2. The coefficient of x here is 7. The coefficient of 1 by y here is minus 4. So now here we are going to write x. This is in a numerator, so x will be x. Here also x is in a numerator. So here y lies below. So here we write 1 by y. Y is in the denominator. Here also y is in the denominator. So we write here 1 by y. X is the numerator, so x. Y is in the denominator, so 1 by y. Now the constant term is 4 and 25 by 2. 4 and 25 by 2. This must be in order. This will be 3, 2 and 4. 7 minus 3 and 25 by 2. Now this is A, this is x equals to B. So therefore when a into x equals to b, then x will be like a inverse b. Now our work is to find a inverse. Now find a inverse. So we're finding a inverse. So for a inverse, first we have to find the determinant of a. Determinant of a is 3 into 1 is 3 minus 7 into 2. 3 into minus 3 is minus 9, 7 into 3 is 14. So minus 9 minus 14 is minus 23. We got a. Then a inverse is 1 by determinant of a into adjoint of a, or the determinant of a is minus 23. Now to find the adjoint of a, we first send the elements that lies the element that lies in the principal diagonal. Interchange the element. You can see 3 and minus 3. Now we change their position, minus 3 and 3. This minus 3 goes here, and then this 3 comes here. Now these 2 and 7 are the remaining elements. We change their sign. If there is plus, we make it minus. Here is also plus, we make it minus. So this is how we got a inverse. Now we have here that x equals to a inverse b. Since x is equals to a inverse b, we put the value. X here is x and 1 by y. X and 1 by y. Here a inverse is 1 by minus 23, minus 3, minus 2, minus 7, 3, and your b here is 4, 25 by 2. Okay, because of lack of space, I have to do this one. Hope that you can consider it. Now I'm solving this thing here. I'm solving it here. You have here x and 1 by y equals to 1 by minus 23. Now we multiply it. Minus 3 into 4 is minus 12 plus minus 3 into 25 by 2 is minus 25. Similarly, minus 7 into 4 is minus 28 plus 3 into 25 by 2 is 75 by 2. Now I'm going to solve this thing. Or x 1 by y equals to 1 by minus 23 minus 12 plus 20 minus 12 minus 25 gives you minus 47. Now minus 12 minus 25 gives you minus 37, and then minus 28 plus 75 by 2 gives you 19 by 2. Let's solve it. X 1 by y. Now this 1 by minus 23 multiplies to minus 47. So when you multiply here, 1 by minus 23 multiplies to minus 37. Similarly, 1 by minus 23 multiplies to 19 by 2. Now when you do this, now we'll get some values for here. X 1 by y equals to, now here you get here 37 by 23, and then here you get here minus 19 by 46. Okay, this so when you equate the corresponding element, on equating you get that x equals to 37 over 23, and then you get 1 by y equals to minus 19 by 46. So the value of y will be minus 46 by 19. So these are the elements, these are the values. Now we can check whether my answer is correct or not. I'm going to check whether my answer is correct or not. Now this is how we check. We got the values for x and y, and we substitute them, and then we check it in the question. Now 3. The value of x is 37 by 23 plus 2. The value of y is minus 46 by 19. I'm going to check this with the help of calculator. Now see how do you do this with the help of calculator here. You had 3 into 37 by 23 plus 2 by minus 46 6 by 19. This much gives you 4. Yeah, we got 4. As you can see in the question, you have 4. Now we checked it for the second equation. Your second equation has 7x, so here we write here 7, and the value of x is 37 by 23, or you can write the 7 into 37 by 23 minus 3 by the value of y is minus 46 by 19, and in this case you get here 25 by 2, as this was in our question. So it means we are correct in our calculation. Now later on we'll be talking about some calculator tricks also. So with the help of these calculator tricks, it will be easy for you to solve the problem. Now this is also to be solved by using a matrix method. Now see, I'm not completely solving it, but I'm showing you the way how to solve it here. Given equations are 7x plus 3y equals to 10xy, and 5x minus 3y equal to 2xy are given equation. You can see xy exists here as well. So at this condition, what you have to do is, I'm going to show you. For 7x plus 3y equals to 10xy. Now I'm dividing each of the term by xy. When you have xy on the right side, then x into y on the right side, then you have to divide each of the term by using by xy. So when you divide 7x by xy plus 3y by xy and then 10xy by xy, you get your question in this way. X cancel, so you have here 7 by y to y cancel, you have here 3 by x equals to xy cancel, you have here 10. Let us write this in order. So 3 by x, writing order means x first, plus 7 by y equals to 10. Now for end the equation, for 5x minus 3y equals to 2xy, or 5x by xy minus 3y by xy equals to 2xy by xy. Now we can cancel this xy. We can cancel x and x, we can cancel y and y. Or you have here 5 by y minus 3 by x equals to 2. Writing this in order. So 3 by x minus 3 by x plus 5 by y equals to 2. Now we got these two equations. Now we can start solving these two equations in a matrix way. So writing in the matrix order, writing in the equations in a matrix form, writing the equation in a matrix form. So I'm writing the equation in a matrix form. The coefficient of 1 by x here is 3, the coefficient of 1 by y is 7, the coefficient of 1 by x is here minus 3, the coefficient of 1 by y is here is 5, and x and y both are in the denominator, so you have 1 by x and 1 by y, and the constant from b is 10 and 2. Now we solve this equation. Now after this we can solve the now after writing the given equation in the matrix form, you can solve this in a way that we solved it previously. So this was just a way to teach you how to solve the problems when you are given in this way. Thank you. So we completed to solve all the possible type of question that comes in a SC exam to solve it by the matrix form. Now we will be doing the Cramer's rules later on. But sometimes if the determinant of a comes to be 0, then you have to say that, you have to mention that the given equation cannot be solved, because we have learned yesterday that if any matrices cannot be defined, it means if any of the matrices has the determinant 0, then those kind of matrices cannot be defined. So if in some case you obtain that A inverse is not is 0, then you have to tell that you have to mention that since A inverse is 0, it cannot be further solved or it can be defined. It's better writing this way also. Now see, I'm continuing the problem this way. Sometimes it's better mentioning these things also. Now here we call Ax equals to B. So therefore x equals to A inverse B. Now we are heading to find so x equals to inverse B. So we are heading to find A inverse. So to find A inverse, we need A and its determinant. Okay. Now to find A inverse, for A inverse, in down over here we have A equals to 3 minus 3 7 5. Now let's find the determinant of A. 3 into 5 minus 3 into 7. 3 into 5 is 15 minus plus 21. 50 plus 21 is 36. So it's better mentioning. It's better mentioning there, since A inverse is not equal to 0. The solution for the matrix has the unique solution. Otherwise, you can write the matrix has its unique solution. It is very appropriate to mention these things. Though I have not mentioned it in previous class, in the previous work, it's very good to mention these things here. Since A inverse is not equals to 0. See, the inverse of since determinant of A. Okay, anyway, since the determinant of A is not equals to 0, the matrix has its own solution. See, the determinant of A is 36. It means that it is not 0, so it is the non-singular matrix. And if it is a non-singular matrix, then only it can be further solved. So since it is a non-singular matrix, the question this matrix has its unique solution. Now further, okay, now we are going to find inverse of A. Now A inverse equals to, or now you can directly start. We have x equals to A inverse B, or x in the question was 1 by x and 1 by y. Previously we wrote it here. A inverse B is 1 by the determinant of A and adjoint of A. Now I will write the adjoint of A. Just change the position of the principal diagonal and change the sign of the remaining elements. And your B was 10 and 2. Okay, now let's multiply it. 1 by x, 1 by y, 1 by 36. Now multiply. 5 into 10 is 50. Minus 7 into 2 is minus 40. 3 into 10 is 30, and 3 into 2 is 6. I am writing it here, okay? 1 by x, 1 by y equals to 1 by 36. Now 50 minus 14 gives you 36, and then 30 plus 6 also gives you 36, or 1 by x, 1 by y equals to 1 by 36 into 36 is 1. 1 by 36 into 36 also is 1. So on equating, 1 by x equals to 1. So the writing on equating means that, so x equals to 1. Similarly, 1 by y equals to 1. So y is also equals to 1. Okay, this much. This is all possible question that might come in the examination, telling you to solve it in a matrix way. Thank you.